We are going to work on solving equations, but today we are going to have variables on both sides of the equation, okay? I want to turn your attention to the fact that Friday we will have a quiz over solving equations. Gonna be fine, okay? Hey, a Friday quiz is the best kind of quiz. Okay. I'm just saying, if we have a quiz on Friday, you don't have homework over the weekend.
That's fair. I'm the same.
All right, here we go. When we are solving equations with variables on both sides, you will need to simplify one or both sides of the equation, okay? Now, on Monday, we talked about these steps, okay? You need to first distribute, okay? If there's nothing to distribute, then you can skip to step 2, combine like terms. I'm gonna write CLT for combine like terms. Is that okay? Kind of like a BLT?
BLT. Make less tomatoes.
Yes.
I don't like the tomato. It makes the bread soggy.
Okay. So you like a BL?
Well, then I add gravy. Well, I usually just eat the bacon.
Okay, so he likes the B. B for bacon. All right. Combine like terms. Now, since we are going to now have variables on both sides, you need to pick one side. Variables need to be on one side, and constants need to go on the other side. Okay. Solve. Solve. We're going to practice playing, don't you worry. Okay. 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 Now, here's the deal. When we have variables on both sides, there can be some crazy things that happen within our problem. Okay. So we're going to talk about how there are 3 different kinds of answers you can get. Okay. I think that would be good. Okay. Okay. So it is possible that we get one solution. That's what you've been doing for the past 3 days. You've been solving for X and you get one answer. Okay. Like, I would. Okay. We could get one solution, which is what we've been doing. Yay, we solve, we get X equals 5, we get X equals 3, we get X equals 275. We get an answer. Okay. Okay. But if we have X's, or whatever our variable is, if we have variables on both sides of our equation, it is possible that the variables cancel out. Well, then what does that mean? Okay.
Some water.
All right, well, there's two different options. One of them could be no solution, but one of them could be infinite solutions. Okay. Yeah. Oh, but that one's tricky. Okay. So in the event that our variables cancel out on both sides, we can get one of these two things to happen. Okay. If we end up getting something like 0, whoops, don't put that there. Put it here. Something like 0 equals 5. Is 0 equals 5 a true statement? No. Okay. So if you end up getting a statement that is not true, because this is not a thing, it means that there's no solution to your equation. There's no variable that will actually plug in and work. But if you get something like this, how many times does 7 equal 7?
Multiple.
Like all the time?
Yeah.
Okay. So if we get a statement that is true all the time, we have infinitely many solutions.
Okay. I'm a little tough.
I don't miss anything. That feels so nice.
Form in here. Okay, let's go to page 15, and we're gonna look at problem number 2. Page 15, so it's just next to it.
I think I know what to do. I think I know resolve it.
Yeah.
Wait, since we're going over it. Never
Okay.
mind.
Okay, so here's the deal. Is there anything that we need to distribute?
No.
No. Are there any combined like terms that we need to do? No, but we are presented with the fact that we have variables on both sides. So we need to pick one side for our variables and one side for our constants, okay? What side would you like us to move the variables to?
Left.
Right.
Let's vote.
What?
Let's vote. Left side, raise your hands. Right side, raise your hands. Okay, we voted on left side. So if I want this 5z right here to be moved to the other side, what operation would move it there?
Subtraction.
We would need to subtract 5z from both sides.
So wouldn't it be 10z?
Negative 10.
It would be 7 minus 10z equals 17. Okay. Yeah, we're just balancing it. Okay. Now, what do we do with the 7? Please make sure the entire coefficient stays with that variable. This is negative 10z equals a positive 10. So yeah, we need to divide by that negative 10 to get z equals a -1. Oh, that's not what I want. Kyron, how do I know if -1 is the right answer?
So 10z is a negative.
Well, how could I like determine that like that is the right answer after I've done all the work?
Oh, you input it back into the original equation.
Okay, what's 7 minus 5 times -1?
Uh,
I don't know.
positive.
No, it isn't. No, it was.
I think that would be +12. Okay, what about 17 plus 5 times -1? When we're solving, we're just checking to make sure both sides get the same thing. I like where your head's at though. How what? So if I put -1 in, I get 17 minus 5, which is 12. And if I put -1 in here, I get 7 plus 5, which is 12. Yeah. Okay, let's look at number 4. Okay. Well, I'm just waiting for everyone to collect themselves. Gabe, what's the first thing we need to do? I feel like we cannot do that yet. We need to distribute first. Okay, so let's go ahead and distribute. Oh man. 3/4 times 48.
32, 36, or 36, 36, 36. My bad. 36 minus 12.
3/4 times -16x.
It's -12x. I don't know. I don't use my brain.
Now we need to distribute the 4. 16 plus 8x. Now you get to decide which side of the equation you want the x's. It feels to me like a lot of you really liked the left side. It doesn't matter, okay? But if you want to keep it as, let's go to the left side, okay, that's fine. So if we do that, how do I get this +8x over to the other side? We would need to subtract 8x. So we have 36 minus 20x equals 16. Jacob, what do we do with that 36? We would need to subtract 36. So -20x would equal -20. This is lame. It's the same answer.
Actually, it's not the same answer.
Oh, you are right. It is a positive one. Who said they don't get it?
Would that be another minus?
Except for the only thing I was off.
Or does the minus sign also add for a negative sign for the next full x?
So since, yes, so we are treating this like a minus sign, so, or a negative, so 3/4 times negative 16 gives us the negative 12.
Shut up. I forgot about the dividing part.
I'm not trying very hard right now. Okay. I'm waiting for you to be quiet. Still waiting for you to be quiet. All right, we're gonna look at number 5 together. Still waiting. Okay. Step 1, distribute. Do we have anything to distribute?
What?
We don't have any parentheses, so no distributing. However, what do we have the opportunity to do? We can combine like terms. It looks like the right side is fine. But over here on the left side, we have 2 terms with Q's. So we can write 3Q, sorry, the right side has 2 different terms with Q's. So we can combine them to be 3Q minus 2. Okay. All right. Now, if we want the Q's on the left, Cassie, what do we need to do with 3Q? How do we get it over to the other side? Yeah, we would subtract it. So we have 2Q plus 6 equals negative 2. Hunter's really excited because the next step is to
Subtract 6 on both sides.
okay. So 2Q is negative 8, which means Q, oh, you'll zip it up for him, but not for me. All right. Let's see. I would like you to turn, well, I guess just slide up, turn. Oh yeah, you gotta turn your page. Yeah, turn your page. We're gonna look at number 10. I would like you to do the distribution and stop. Distribute and then stop. When you distribute, you have 3x minus 24x. Oh, that's not it. Minus 16x. I'm so excited because this is minus 24.
Oh, I get that right.
Please make sure you are distributing the negative with the 8 to both terms. And then over here, we have negative 12x minus 30. Finish it out.
Is this a negative?
Look at the sign. Are you asking about negative 24?
Are we gonna have any solutions today?
We're gonna get to a couple here after this.
We can have someone. Oh, come on.
It's actually less work.
It's so hard.
It's not
Well,
hard.
actually. Well, it's still, I feel like it's gonna be the same amount of work.
I don't remember.
It's either solution or no solution based off of the number equals what it does.
Allison. You get positive 6.
Work. No, it's not. It's not. Miss, how many are positive?
Okay, we're having some arguments. Let's get something settled. So the first step you need to do is combine like terms over here on the left. So this should get you a negative 13x minus 24 equals negative 12x minus 30. Okay. If you want the x's on the left, then you can add 12x to both sides, but you would have negative x minus 24 equals negative 30, right?
Yeah.
Okay, if we add 24 to both sides, then we have negative x equals negative 6, which would mean positive x equals a positive 6.
I said positive.
Hey, whoa, whoa, I love that you want to talk about math. But I'm sort of feeling that that's not what we're talking about right now.
I was talking about that.
Okay, Noah, what are you talking about?
I was saying Kyra said it was negative 6. Oh, it's positive.
Okay, bro, we don't have to call each other out for making mistakes. Okay. All right. Stupid, that word's not allowed in my classroom. All right, number 11. Number 11. Kaylee, what do we need to do first in number 11? We need to distribute. So we get 24s plus 72 equals 24s minus 112. All right. If we want to get the variable to the left side, you've told me that that's kind of what you like, then we would need to take this 24s and subtract it over.
And that doesn't exist.
All right, what happens? Our s's cancel out and we have 72 equals negative 112. How often does 72 equal negative 112? Never.
Can you say not?
I want you to say no solution because I'm asking you, what is the solution? You're telling me, hey, Miss Holman, there isn't one.
You lied to me. Do we have to add an exclamation
mark?
No. No.
Do we need that?
You can find the solution.
Oh,
It's a squiggly line that we have to put down.
no, that's just me making some emphasis. Like,
What about the no?
just write no solution and I'll be fine. And if you misspell it, I won't judge you. All right, let's look at number 12. I'm just waiting for quietness. Okay, in number 12, if we distribute the 8, then we get 16f plus 24. Some of you can see where this is going. Okay. we can subtract 16f to the other side. However, both sides, our variables are going to cancel out. And we end up with 24 equals 24. Drew, how often is 24 equal to 24? All the time, infinite. This means we have infinite, oh no, infinite solutions. You don't need to squiggle. There. The Spanish exclamation points. All right, now. Is this yours?
Yeah.
That you left here overnight? And you thought it was a good idea to throw it to Brooks. And Brooks, you thought it was a good idea to throw it back. Yeah. You can stay through a passing period. 23. Now, I would like you to make an observation of number 11 and number 12. Kari, how do they look the same? Connor.
What? Oh, no. Was I right?
I mean, there is something that happens in both of these that I want you to make an observation of.
Oh, they both distribute.
Okay,
They both have to be, they use fractions to divide and make half the number. Because in number
you're
13,
stretching.
you have to do 10 divided by 2.
I'm talking about 11 and 12.
Oh, never mind.
Okay, okay. Okay, and so what's true about the coefficient on the left and the coefficient on the right? They're the same. That's why the variables canceled out. Okay, so when you see that, oh, my variables are the same on both sides, their coefficients, you know one of these cases is going to happen. When they cancel out and you're left with an untrue statement, we have no solution. When they cancel out and you're left with a true statement, you have infinite solutions. Yes.
What if it's like 5 equals 10?
Does 5 equal 10?
Well, no, but like,
No, never, ever does 5 equal 10. So that would be this case.
okay.
Okay. I know that we can do something to 5 to get 10, but we can't think like that.
Okay, yeah.
Okay. Okay. But that's, I mean,
Yeah.
I like that the wheels are turning.
You have to get the numbers are.
Here, yeah. Numbers aren't the same, no solution. Okay. All right. So here's the deal.